intelligence, and they're like, the
No.
apple plus the cat equals
I hate that.
All right, so it's called multivariable systems, but it really just means 3 variables and 3 equations. So it is just like a system like we did before, except for having just x and y, we're going to have x, y, and z. So this is the process every time, and it looks like a lot of words. I'm going to read it out loud. Obviously, when we practice it, we will learn these steps, but this is just to help you. Maybe if you get stuck and you don't know where to go, you can come back to this slide. So you're going to pick 2 of the 3 equations, any 2, and you're going to cancel out one of the variables, and it can be any variable. Then we're going to call that new one. So we're going to give it like a name so we could refer to it. Then we're going to pick the third equation that we didn't use the first time. You have to use that one, but you compare it with either of the other 2 already used, and you have to cancel out the same variable. So if I canceled out an x the first time, I have to cancel out an x the second time. If I canceled out a y, I have to cancel out a y. If I canceled a z, I have to cancel a z. And then that new equation we're going to call new 2. Then we use new 1 and new 2 and our normal systems of equations, because there will only be 2 variables. We will narrow it down to 1 variable, solve it, take it, plug it back into one of the new equations, and we'll solve for the second variable, and then we'll take those 2 and plug them back into one of the original equations to solve for the last variable. So they would look something like this. I'm going to number these so that we can refer to them. So this would be 1, 2, and 3. And your goal is to think about what you have to do. I have to pick 2 equations and cancel out a variable, and then I have to pick another 2 equations and cancel out the same variable. If you look at line 2, what do you notice about line 2? There's only 2 variables, so there's already a variable missing there, right? So we can actually leave that equation out for the first step and pair the other 2 up and cancel out the variable that's already canceled from there. I said there's going to be a bunch of random slides in there. Go ahead and delete them out. Yeah, it's just the template. So I'm going to take lines 1 and 3, and I'm going to cancel the z so that I can then pair it with 2, because that one's already got the z gone. So if I grab 1 and 3, I have x minus 2y plus 3z equals 9. And then I'm going to grab 2x minus 5y plus 5z equals 17. Now I want to cancel out the z, so I'm going to multiply the top row by a negative 5 and the bottom row by a positive 3. And I get negative 5x plus 10y minus 15z equals negative 45. And I get 6x minus 15y plus 15z equals 51. Now I'm going to add these 2 equations just like we do with elimination, and I get x minus 5y, this cancels, equals a positive 6. This is my new 1. So I grabbed the 2 equations that actually had the 3 variables, canceled out the same variable that's missing from that second equation. Now if this wasn't already missing an equation, if that number 2 wasn't already missing a variable, then I would have to take 2 and I could pair it with either 1 or 3, and I have to cancel out the same variable I already canceled, which we're going to see examples of that in a minute. This one is kind of special because it has a line that already has 1 canceled out. So I'm actually going to use this 2 with my new 1, and I'm going to use elimination. So if I add these as they are, will a variable cancel out? Yes, right? My x's are going to cancel. So I don't even have to change these. I can just add them. These cancel. I get negative 2y equals positive 2, and y would equal negative 1. That's my first variable. Now I need to take that one and plug it into one of the equations that only has 2 variables. So I can either plug it in here or I can plug it in here. Doesn't matter which one. So let's say I plug it in here, I'd get negative x plus 3 times negative 1 equals negative 4. Negative x minus 3 equals negative 4. Add the 3. Negative x equals negative 1. Divide by negative 1, and I get x equals positive 1. Now I've got my second variable. And I have to take these two and plug them back in to one of the originals that has 3 variables. So I'm just going to grab the top one, x minus 2y plus 3z equals 9. Plug in the x, plug in the y, and we're going to solve for z. 1 plus 2 plus 3z equals 9. 3 plus 3z equals 9. 3z would equal 6, and z would equal 2. So my solution here is my x, which is 1, my y, which is negative 1, and my z, which is 2. Hallelujah. All right, so like I said, that first one was kind of like a special case because one of them only had 2 variables. More of them will be like this. So if we look at this one, 3 equations, all 3 variables. So again, I'm going to number these so we can refer to them as 1, 2, and 3. Now I want to cancel this. I want to pick 2 equations, cancel out a variable, and then pick another equation, the last one that wasn't used, and cancel the same variable with one of the other ones. So you're going to want to start to plan ahead and make it as easy as possible on you. Look at your variables. Look at your x's, your y's, and your z's. Which letter is going to be the easiest to cancel twice?
3.
So maybe z. If I pick 2 and 3.
3 is a letter.
3, it's okay. If I pick, it's very early on a Monday morning, I get it. If I pick 2 and 3, I can cancel the z's right off the bat, right? Then I have to use 1 the next time around, and I want to cancel out the z again, but I could do like a 1 and a 2 and multiply 2 by 6 to cancel it out. So you want to start to plan ahead, make sure you're not setting yourself up for something much more difficult on the second time. So let's do that. We're going to do 2 and 3 first. So 2 is 2x plus y minus z equals 2, and 3 is x plus y plus z equals 2. And we're going to add these. So 3x plus 2y, this cancels, equals 4, and we're calling this new one. Then I have to use the equation I didn't use the first time, which means I have to use 1. And I have to cancel the same variable I canceled the first time around, which was the z's. So I want to take 2 because the z is already negative. So I'm going to use 2, and I'm going to multiply it times negative 6. So, I'm sorry, times a positive 6. So this whole thing is getting multiplied by positive 6. I get 12x plus 6y minus 6z equals, and be careful, make sure you go all the way to the other side of the equal sign with that 6. I get 15x plus 15y equals 15. And this is new 2. The first one we find, we call new 1. The second one we find, we call new 2. Yeah, it doesn't matter. It's just so that we can refer to them later. Okay, now I have to use new 1 and new 2 and narrow it down one more time. So I'm going to take these two, 3x plus 2y equals 4, and 15x plus 15y equals 15. And I need to cancel out either the x's or the y's, which is easier to cancel out. The x. So I'm going to multiply the top by negative 5. Negative 15x minus 10y equals negative 20. These cancel. 5y equals negative 5, and y equals negative 1. So now I have my first solved variable. To get to the second one, I have to plug it back into a new 1 or new 2 equation. I think it's obvious that it's easier to plug it into here because these are just smaller numbers, but it doesn't matter which one. 3x plus 2 times negative 1 equals 4. 3x minus 2 equals 4. 3x equals 6, and x equals 2. Now I've got my second variable solved for. And I have to take and plug those back into one of the originals to solve for the last variable.
Wait, so when you're solving for the second variable, you plug it into one of the new ones?
Correct.
And then the last one, you plug
One of the originals. If you do that wrong, like if you plug it into one of the originals, you're going to have two variables that you don't know. So you'll catch it. You'll be like, shoot, how do I solve this? Because there's three variables and you'll only have one to plug in for, yeah. So it goes from the 1 into the one with 2 into the one with 3. So now I'm going to take these two, the negative 1 and the positive 2. I'm going to plug it into one of the originals, and I would probably say pick the bottom one. It has no coefficients. So x plus y plus z equals 2. 2 plus a negative 1 plus z equals 2. 2 minus 1, 1. Subtract the 1, and z is 1. Now I've got all three, and I put them in order, x, y, z.
So you can plug them into any, equation that you have?
Once you find the first one, you plug it into either of the new ones. And then once you find that second one, you can plug it into any of the beginning ones.
So also, how do you know after you find the first new one which equations you can use, or could you use any?
After you find the first new one,
Yeah, like
you
just,
have to use the third equation you didn't use the first time.
okay.
But then you compare it with either of the other ones.
Oh, okay.
So you have to use the one you didn't use because you have to involve that in a system. But you could pair it with either of the original ones.
Mhm.
You just want to eliminate the same variable you did the first time. All right, let's do another one. Okay, so we're going to number these. 1, 2, 3. Somebody give me their plan, because you could do a couple of different things.
We are gonna do 1 and 2.
You're going to pick 1 and 2, and you're going to eliminate what variable? The y. So 2x plus y plus z equals 9. Negative x minus y plus z equals 1. Add x plus 2z equals 10. Here's my new one. Okay, so now we have to use 3 because we didn't use it the first time. And we have to cancel y. So what would you pair it with?
That would make sense. Oh, I just need to look up.
Oh, wait, yeah.
Okay, sorry, wait.
I had to use 3 because we didn't use it the first time, right? And we have to cancel y. So if I'm going to use 3 and want to cancel out y, which one do I pair it with, 1 or 2? 1.
1.
Good. 1, 2x plus y plus z equals 9. It's not wrong to choose 2. You just would then have to multiply one of them by a negative 1. But you still get the right answer.
No, I think I just did a whole complicated process. I took 2 and multiplied the bottom one by 2, and then I realized I could have just left it. And
Yep.
it would have canceled.
Here's new 2. Then you have to pair new 1 and new 2 together. And we want to cancel out one of those variables. You've got options. What's one?
Z.
I can cancel out the z, so I could just multiply everything maybe in the top or the bottom by a negative 1. Negative x minus 2z equals negative 10. And I get 4x equals 8 divided by 4. And x is 2. And that's my first variable. Now where can I plug that in to get the second variable?
New one.
Good. I can plug it in a new 1 or new 2. New 1's probably easier just because there's an x. So I get 2 plus 2z equals 10. 2z would equal 8, and z would equal 4. Now I've got my second variable. And I have to plug that one in where?
Yep.
I think you said 2. Yeah, one of the originals, and I would have probably picked 2. So negative x minus y plus z equals 1. Negative 2 minus y plus z, which is 4, equals 1. Negative y plus 2 equals 1. Negative y would equal negative 1, and y would equal positive 1.
I was just about to ask a question, but I realized I already asked.
Do you know the answer to it? Okay, then you're good. Good job. You answered your own question in your head. So here's the thing about these kinds of questions, just like your other systems, you can always check these. I can always take those and plug them back in. They have to work in all 3 lines in order for it to be 100% checked, okay? That's a big if. If you have extra time, you can do that. But obviously, these take a little bit of time, and when you pair it with a couple of the other questions from the other sections, you know, you just got to watch your time.
How much time and how many questions?
So right now, we have 5 questions and 30 minutes. Yeah, this one takes a while. So,
Do you think that it's going to
all right, we're gonna do it again. Number them. 1, 2, 3. Wait for it.
Boring.
Okay, so we want to take and cancel out again. Well, you want to pick 2 equations, cancel out any variable, and then have to pick that third, cancel the same variable. So pick one to cancel.
Right. You don't have time to sit right now.
Okay, if I pick 1 and 3, what variable are you going to want to cancel out? The x. Okay, so we're going to leave 1 by itself, just so we're consistent. And then we're going to multiply 3 by negative 1. So I get negative x minus 2y plus 3z equals 1. Feel free to write that in 2 steps if you want. Like you could write out 3 and then change it. Just be really careful if you're going to do 2 things at once. These cancel. Negative 5y plus 4z equals 0. Here's my new one.
Why does it make this one?
Because I got 1, negative 1.
No, where's the negative one come from?
I multiply. The negative one is, I wrote it wrong. This should be 2. Just proving a point. See how easy it is to make a mistake? Okay. Now I have to use the second one. And I have to cancel out x again. So pick, it doesn't matter because we're going to have to multiply each of them by negative 2, right? Let's just say we're going to pick the top one. We're going to do negative 2 times 1. And I get negative 2x, positive 6y, negative 2z equals negative 2. Cancels. 5y minus 4z equals 0. New 2. I did the first, well, I took 2. We had to use 2. This is 2. I used 2, and then I took the first one and I multiplied it by negative 2. Okay, so now I've got my 2 new equations. I have negative 5y plus 4z equals 2. And I have positive 5y minus 4z equals 0. What happens when I cancel these out? I get a false statement, which means
No solution.
no solution. So just like before, if it happens anywhere in here that it doesn't work, it's no solution. The all real numbers you have to be careful with because it has to cancel twice. So all real numbers would, because you can't just pair 2 equations, I'd have to make sure it has to be with the new 1 and the new 2 when it happens for it to cancel. So if it happened from the beginning, like if it happened with one of my initial ones, I have to then use that third equation to make sure. Less work. But my advice, make sure you go back and check. So on the Canvas quiz, because that's obviously if you're taking it home, you're taking it on the Canvas quiz, this kind of answer, it's either going to accept NS or it's going to accept no solution, all lowercase like that. But you could also just put NS if you got a no solution on one of your systems. All right, now this one's even weirder because what?
They're only, so
different.
only one of them has all three variables.
Only one of them has all three variables. So if I have to pick two and cancel out a variable and then pick another one, what could you choose? Because there's more than one thing you could choose. So I'm going to number these so we can talk about them. 1, 2, 3. I obviously have to cancel something from 1. So let's say I pick 1.
And 2, or 1 and 3. I like 1 and 2 better.
You want to do 1 and, let's say we do 1 and 2. 1 and 2, right? X plus y minus 3z equals -1, and then y minus z equals 0. So you technically have two options here. I could work to cancel out the y's, or I could work to cancel out the z's, right? But before we do that, look at this third one. What's already canceled from there? Z. So my recommendation is cancel out the z's from the first one. So cancel the z's here. Change this by maybe multiplying by a -3. So my first one stays the same. It's x plus y minus 3z equals -1. And then the second one, -3y plus 3z equals 0. I get x minus 2y, these cancel, equals -1. And this is my new one. You could have done it. You just get different numbers along the way, but you just get the same answer. Okay, so now I have that one. And I have to use 3. So I'm going to pull 3 over. -x plus 2y equals 1. I don't have to cancel a variable from 3, and I don't have to pair it with another equation as long as at this point I have used all 3 equations in this involvement, which we did. We used 1 and 2, and then we just pulled in 3. Now, when we cancel, we get 0 equals?
Oh, never mind, all solutions, right?
Yep.
What?
Wait, all of them?
What? I thought you're supposed to, when you do it, cancel it with the.
But you already have it, right? As long as I use that third equation, I don't have to alter it. I just have to include it in the process. So I could, that's why we canceled out these the first time, so I didn't have to do it again. You can, let's just say, because you wanted to pick which one? You wanted to pick 1 and 3?
Yeah.
So let's say you picked 1 and 3, and what was your plan to cancel out the x's? So then you automatically go, now you have a y and a z, yeah? Now look at 2. 2 already has the y and the z. You could have just used the result of that with 2. So when it's like an all real number situation, no matter which ones you pick, you will get all real numbers. When it's a no solution, no matter which ones you pick, you will get no solution. So it doesn't matter how you do it as long as you do it correctly. This would be all real numbers.
Question.
Yes.
So when could you do like any like for any of the problems, could you put like the third one there with any of the new ones?
Yep. Oh, not with the new ones. You mean if it had canceled out? If my third one was already missing a variable, you mean?
No, I'm talking about for like if they had all of them had all 3.
So if all of them had all 3, when you go to find that third one, you have to cancel out a variable. So you have to use another, and you can't use a new one. You have to use another one of the original ones. Because you wouldn't be able, so think about it, right? If you went to use this third one, and it had a z in it, right? And I go to use it with a new one, I can't, right?
Yes.
Because you wouldn't have the same variable there to still cancel out. You wouldn't be able to cancel it out.
Okay.
You'd get stuck. You hopefully would know that not to do that. So if it's an all real number situation, you can write ARN. It will say it on the test, but it would be ARN for all real numbers. Okay, again, if you're taking this at home. Still good? Yes? All right, see how far you can get. Okay, this was 6. So we did 1 and 2 and canceled the z's. Again, your process could be different as long as your answer is still the same. And this is going to be a good chunk of points. We haven't finalized point values, but this is a good chunk of points on your quiz on Wednesday. So keep in mind that like you will earn points for getting to certain, I would always say like little pit stops. So if you can get to the new 1 and new 2, you'll earn a little bit of points. If you can get to single out one variable, you'll earn a little bit more points. So it's not like an all or nothing shot, okay? So don't get entirely frustrated, and for the love of God, do not erase your work, okay, when you get to this kind of a question. So we canceled the z's for both the new 1, new 2, and then ended up with x equals 2. Plug that back into, I plugged it into new 2, and I got that, where'd that work go? On the blue, the purple in the middle. Y is -1, and then plugged them both into the first equation and got z was 1. So my answer 2, -1, 1. This is the last one. So again, depending on your picks, you might have gotten different new 1s and new 2s, but in both cases, you should have gotten them to cancel out and leave you with a false statement. So for me, I canceled out the y's, and I ended up with 5x plus 9z equals 8, and then 15x plus 27z equals 19. I multiplied the new one by a -3, and I got -15x minus 27y. Oh, those should both be y's.
I only got one.